This is a video from section 6.3. We're going to use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curves about the y-axis. So we're going to take a look at number 9 in the Stewart calculus textbook. Suppose we have the curve y equals square root of x, which is the first curve, y equals 0, which is essentially a line, and then x equals 4. And so we're going to take a look at a picture. And so we have the x and y axis. Now, if we graph y equals square root of x, when x is 0, y is 0. When x is 1, y is 1, because the square root of 1 is 1. And then when x is 4, right, that's out here, y is 2, that's up here. And so we have y equals square root of x right here. We have x equal 4, and then that's over here, right, that I'm drawing, that I'm highlighting. And then y equals 0 is along here in blue. Now, what we're going to do is we're going to draw a representative rectangle right here. And we're going to rotate that rectangle around the y-axis. And so this is going to be broken up into 3 parts. This is how I think of cylindrical shells. We're going to look at the circumference. Now, to get the circumference, we're going to take 2 pi times the radius. And to get the radius, it's going to be the distance from the y-axis out to the rectangle, which in this case is x. So it'll be 2 pi x. The height, we're going to look at the height of the rectangle, which is the distance from the curve down to the x-axis, which is going to be square root of x. So the height is square root of x. The thickness, think of the width of the rectangle, is going to be dx. And so when we look at the volume, we're going to take the integral from x goes from 0 out to 4. So we're going to go from 0 to 4. We're going to get the circumference, which is 2 pi x. We're going to multiply by the height, and then we're going to multiply by the thickness, which is dx. And then we integrate. So this is the integral from 0 to 4 of 2 pi. Now, x times square root of x is x to the 3 halves. So it's 2 pi x to the 3 halves dx. So this is 2 pi times. Now, 3 halves plus 1 is equal to 5 halves. So this is 2 pi times 2/5 x to the 5 halves, evaluated from 0 up to 4. Okay. Now, this is 4 pi over 5 times. I'm going to replace x with 4, and I'm going to get 4 to the 5 halves. I'm going to replace x with 0, and I'm going to get 0 to the 5 halves. And I'm going to subtract those two quantities. Now, square root of 4 is 2, so that denominator of 2 tells me to take the square root of 4. So square root of 4 is 2. 2 to the 5th is 32. And so this is equal to 4 pi over 5 times 32. So the answer to number 9 is 128 pi divided by 5. Let's take a look at number 11. suppose y equals 1 over x, y equals 0, x equals 1, and x equals 4. And so it's really important that we draw a picture. Here's y, here's x. Now, when x is 1, y is 1. That's here. When x is 4, y is a fourth. Let's say that's here. So we're going to look at something like this. So we're going to look at this region here. And then, by the way, y equals 0 is highlighted in blue here. That's the x-axis. But we're looking at that region right there. And I'm going to draw a representative rectangle in red, and we're going to rotate that rectangle about the y-axis. And I'm going to do the same game. We're going to look at the circumference. The circumference is 2 pi times the radius, which is x. The height, well, the height is 1 over x. The thickness is dx. And so when I want the volume using cylindrical shells, I'm going to take the integral from, now x goes from 1 up to 4. So we're going to go from 1 to 4. We're going to take the circumference, which is 2 pi x. We're going to multiply by the height, which is 1 over x. And then we're going to integrate with respect to x. So that dx is representing the thickness. So this is the integral from 1 to 4. The x's cancel, and you're integrating 2 pi dx. But that's 2 pi x evaluated from 1 to 4. And so when I come over here, I get 2 pi times 4 minus 2 pi times 1. And so the answer is 7. Well, here, let's slow down. 2 times 4 is 8, so this is 8 pi minus 2 pi. So really the answer is 6 pi for problem number 11. Let's take a look at problem 13. Suppose we had y equals the square root of 5 plus x squared, y equals 0, x equals 0, and x equal 2. Like so. Now, here's y, here's x. So this is some curve, right? Now, when x is 0, y is the square root of 5. So that's somewhere between 2 and 3. And so we're going to say that square root of 5, let's say, is somewhere here. Now, when x is 2, so we're going to go over 2, y is going to be 3, exactly 3. And that's going to be a curve. Let's say the curve does something like this. We just need it to do something, okay? Now, x is 2 is here. X is 0 is here. We'll highlight that in blue. And then y equals 0 is along the x-axis here. So we're looking at that region and we're rotating about the y-axis. And so I'm going to draw a representative rectangle that's going to be here. Okay, and we need the 3 pieces again. We need the circumference. Well, the circumference is 2 pi x. The height is the square root of 5 plus x squared. The thickness is dx, just like this. So when I want the volume, I'm going to take the integral from x goes from 0 out to 2. So we're going to go from 0 to 2 of the circumference, which is 2 pi x, times the height, which is square root of 5 plus x squared, and then times the thickness, which we'll call dx. And this is classic u substitution. So we're going to let u be 5 plus x squared. Du is 2x dx. Now, when x is 0, u is 5. When x is 2, u is 9. So we need the limits in terms of u's. Now, I'm going to pull the pi to the outside, and I'm going to integrate from 5 to 9 of square root of u du. So this is pi times 2/3 u to the 3 halves, evaluated from 5 up to 9. So I could pull the 2/3 out in front as well. So this is 2/3 pi times 9 to the 3 halves minus 5 to the 3 halves. But the square root of 9 is 3, 3 cubed is 27, right? So this is 2/3 pi times 27 minus. Now, 5 to the 3 halves is just 5 times the square root of 5. And I think this is a pretty acceptable way to express your answer. And that's number 13. Now, what if the direction said the following? Use the method of cylindrical shells to find the volume of the solid obtained by rotating the region bounded by the given curves about the x-axis system this time. And with that in mind, we're going to take a look at 15. So on 15, suppose we had xy equals 1, x equals 0, y equals 1, and y equals 3. Okay, so here's x, here's y. So let's take a look at a picture. Now, when y is 1, if I plug 1 into the first curve, can we agree that x is 1? And so I'm going to come over here and I'm going to plot 1, 1. If I plug y equals 3 into the first curve, I get x equals 1/3. So I'm going to, let's say, come over here, and I'm going to go up 3. Let's try that again. So 1 is here. We'll call that 2. We'll call that 3. So that's about here. And so we're going to look at a curve that looks like this. Something like this. Now, x equals 0 is here. That's along the y-axis. Y equals 3 is here. And then y equals 1 is over here. And we're going to rotate about the x-axis. That's over here. Now, we're going to draw a representative rectangle, but keep in mind we're rotating about the x-axis. And so I'm going to make the rectangle horizontal. So it's going to look like this. Now, it's going to be the same game. We need the circumference. Well, the circumference is 2 pi times the radius. But the radius is the distance from the rectangle down to the x-axis, which in this case, since we're going up and down, this is going to be y. So it's going to be 2 pi y. The height of the rectangle? Well, if I solve for x in terms of y, the height is 1 over y. And the thickness for this question is equal to dy. So the volume is going to be the integral from. Now, y goes from 1 to 3, okay? I'm going to take the circumference, which is 2 pi y, times the height, times the thickness. So this is the integral from 1 to 3 of 2 pi, the y's cancel, and so it's basically 2 pi dy. But this is 2 pi y from 1 to 3, which is 2 pi times 3 minus 1. So the answer here is 4 pi. Let's take a look at number 17. Suppose I give you y equals x to the 3 halves and x equals 0 and y equals 8, like so. We draw a picture. So here's y, here's x. When x is 0, y is 0. So I'm going to draw this curve first. When y is 8, I need to basically solve for x. And so I claim x is 4. Okay. So I'm going to come over 4, and I'm going to go up 8. 2, 3, 4, 5, 6, 7, 8. Okay? And so suppose we get a curve. Now, by the way, when x is 1, y is 1, so that's here. So it's probably doing something like this. Okay? We have y equals 8, which is here. And then we have x equals 0, which is here. So we're looking at this region, and we're going to rotate that region about the x-axis. And so I'm going to draw a representative rectangle here. Okay. Now, remember we have three pieces. We have the circumference. Well, that's 2 pi times the radius, which is going to be y. We have the height. Now, we need to solve for x in terms of y, and then, so I claim x is y to the 2/3. Okay? So that's going to be y to the 2/3. And the thickness, so again, cylindrical shells I remember in three pieces. Circumference, height, thickness, dy. And so I want the volume. Y goes from 0 to 8. I'm going to take 2 pi y, that's the circumference. The height is y to the 2/3 times the thickness, which is dy. So I'm going to pull the 2 pi out in front, and I'm going to integrate from 0 to 8 of y to the 5/3 dy. Now, 5/3 plus 1 is equal to 8/3, right? And so this is 2 pi times 3/8 y to the 8/3, evaluated from 0 up to 8. Now, I'm going to pull the 3/8 out as well, so this is going to turn into 3/4 pi times 8 to the 8/3 minus 0. The cube root of 8 is 2. 2 to the 8th is 256. And so this is 3/4 pi times 256. Now, 4 goes into 256 64 times, and 64 times 3 is 190. Here, let's check that. 64 times 3, I'm old school. Looks like 192, so this will be 192 pi. And that's going to conclude this video for section 6.3. We worked problems 9, 11, 13, 15, and 17. Thank you.